Welcome back. It is 9:36. It is time for the Naked Scientist. And you are going to need a WhatsApp number if you want to put a question to Dr. Chris Smith, consultant virologist at Addenbrooke's Hospital in Cambridge. The Naked Scientist joins us on air once more to answer a variety of science and medical related questions. You can get your questions through on WhatsApp 0725671567. Hey, you can call, beat the queue on 021 446 0567. Dr. Chris Smith, good morning and welcome.
Good morning. How are you doing?
Always good. Thank you. The sun's shining. It's looking like a beautiful, very beautiful winter's morning in Cape Town.
Yeah, I wish we could say the same, actually. We are basking in the glow of an inferno rather than the sunshine. Lots of wildfire activity not far from where I am in the southeast of England, and half of the UK now officially in drought. The whole of the country of Wales in a drought, and other countries around the world similarly afflicted by serious fire activity. Look at France, for example, where Bordeaux, where the wine comes from, massive fire activity. People are saying, well, will this impact on the grapevines? Yes, but indirectly. It won't burn them. But in fact, there's a huge headache for the wine industry, which is when smoke gets into the air, the smoke gets onto grapes, and smoke taint, chemicals in the smoke, then end up in the wine, and it ruins any wine you might make. So this costs the industry billions. I know South Africa has problems with this from time to time as well. But there might be hope on the horizon, because I was talking to a guy the other day who's got a very clever electrochemical technique where he can actually modify the molecules which are in liquids by electricity and remove specifically certain molecules. And they reckon they know what some of the molecules that cause smoke taint are. So they're now trying their technique out to clean up dodgy wine and remove the smoky smells, so you can turn something that was impossible to sell into something that has value again.
Yeah, okay. And yeah, it's pretty widespread in Europe. It's been a very hot season, and strength to you. I got a message in from Michael. He's a medical doctor. And we were talking about statistics, and I just thought I'd mention it to you because you would concur with the statistics that he cites. He says statistically, the average person has one breast and one testicle. Have a liquor day, Clarence. You would concur with that statistic.
One breast, statistically, a person has. Does he mean because of averages? Is that what he's getting at?
That's the only conclusion that I.
Yeah, well, no, because you think, if you work it out, I mean, that's one way of looking at it. But some people do naturally have one of those things. Some people actually have more of those things. And some people end up with just one of those things because of various things going wrong. So, yes, I suppose statistically, he's right.
Okay, let's go to Zuki. Zuki, welcome. It's always great to have you.
Morning, Clarence, and morning, Dr. Chris. Okay, if Dr. Chris could please explain the physiology of an itch, because I've noticed recently that, so I have a rash, right? It doesn't itch all the time. So what is it that triggers the itch response? Because sometimes it also just goes away randomly. And it's not like even in the same area, the whole area is itching. So what exactly is it that causes that itchy feeling? What triggers it?
Oh dear, you've done it now, because I'm scratching, and I suspect half the population who are listening to this are now beginning to think, scratch, scratch, scratch. We have a population of nerve cells in the skin whose job it is selectively to signal itch. And they project back to your spinal cord, and when they become active, they tell the part of your spinal cord that responds to signals from that patch of the skin that this region of the skin is itchy. Now, it's not just a one-way street, though, because when the area of the body that is itchy is itching, there are also signals going the other way down nerve fibres onto cells called mast cells. Mast cells make histamine, and so when the itch signal activates, you can also make more histamine come out of mast cells, and histamine makes you itch. It makes swelling, it makes the skin go red, blood vessels open up, and it activates more itch. What does that do? That makes your attention get drawn to that part of your body, because we've evolved this behaviour so that we can defend ourselves against things like mosquitoes trying to bite us. If you've got an itchy patch, you need to pay attention to it. What's our reaction? We scratch it. When you scratch it, you're actually inflicting a little bit of pain on yourself. The pain activates a different population of nerve cells who are a much higher threshold. You actually need to do a bit of damage to activate those nerve cells. They feed back into the spinal cord, and you probably guessed it, they send a pain signal up to the brain. This bit hurts, but at the same time, they turn off the signals coming in from the itch nerves. So it's a bit like pressing a reset button on an itch. The itch draws your attention to that part of the body. The scratch presses the reset button. But in the process of scratching, you actually perturb the tissue more, and you can make the itch come back more. And it's called the itch-scratch cycle. If you talk to a dermatologist or skin expert, they'll say this is why people with eczema or atopic dermatitis will scratch themselves, feel better, and it feels lovely having that first scratch. But then a few minutes later, it's back again with a vengeance, to the point where you then scratch even harder, and you've guessed it, do more damage, which gives you momentary relief, but then you're back again with an even bigger itch. This is the vicious cycle that we have to make sure we try to break. And under normal circumstances, a person doesn't end up with that cycle going around too many times, so they don't do damage to themselves. But if there's damage to the skin, like eczema, then you can end up in a vicious cycle of you scratch because you itch, which makes you scratch, which makes you itch, and it gets worse and worse and worse until you've done damage. But most of these itchy signals, they are not really finely localized to one patch of the skin. The receptive field, as it's called, for that particular group of nerves, for a patch of skin, for an itch, is very big. What do I mean by that? Well, if you reach into your pocket and you feel around with your fingertip, you will be able to find a coin, a key, a small object, and you'll be able to work out what its shape is with great accuracy. But if you tried to do that with the skin on, say, your wrist, you wouldn't succeed, because the receptive field of the nerves on the end of your finger is very tiny, great resolution. Elsewhere on the body, big patches of skin get activated, and you touch yourself there, and you feel it over a big patch of skin. That's a big receptive field. Itch works that way. So itch is poorly localized, which is why it seems to sort of jump around all over the place, rather than being in one discrete place.
Okay, we got two questions in about tortoises. So let's go to the first one in at 9:07 this morning from Vernon. It reads, is it possible for a tortoise to survive for 10 years sealed up in a building, as mentioned on some social media sites, as per a tortoise found in Brazil? That's the first question. Roy asks a different question. Why did sharks and tortoises develop carcinogenic fighting abilities and not humans?
I'm sceptical that the tortoise could survive 10 years. That does seem an extraordinarily long time, but these animals are cold-blooded. They can have a very low metabolic rate, and sailors used to take giant tortoises on boats because they could flip them over, and the tortoise was its own storage vessel. They could use the tortoise would sit in its shell and sleep on the boat until they wanted to eat it. So it would sort of keep itself fresh, but because the tortoise was cold-blooded and could just be dumped in the bottom of the ship, it would survive for long periods of time without you having to do much to it. Cruel, but unfortunately people were back in the day. 10 years, that seems a very, very long time. But you never say never in science. So I'm willing to have a look if anyone's got a story I can poke into and take a look at that to see whether or not the evidence stacks up. Very happy to do that. I'm not aware of these animals having carcinogenic properties, though. Carcinogenic means causes cancer. And if you've got something in your body capable of
fighting properties.
Yes, but to be carcinogenic, you've got to be capable of causing cancer. So you've got to have something in your body capable of causing cancer, which would beg the question, well, if it can cause cancer, why doesn't it cause cancer in you? So again, if someone has a reference for that, or what they're referring to specifically that I can look into and then clear that one up for you, please send me the details and I'll quite happily take a look.
Roy and Vernon, you have homework. Get it through to the Naked Scientist. Anne wants to know why her elderly dog's behavior changes at night. Not sleeping, confusion, walking around, etc. And is there a cure?
Well, the same thing happens in humans. As we get older, we tend to see our sleep patterns change. An older person needs less sleep than a younger person. An older person tends to stay asleep for a shorter period of time than a younger person, probably because they catch up and nap during the day. And that means the overall amount of sleep is possibly approaching the same, but it's more fragmented. And also, as we get older, our cognition deteriorates, one of the signs of things like Alzheimer's disease is that people do show a disruption in their sleep-wake cycle, and they also tend to wake up at night and then go wandering around at night. And this is one of the things that anyone who cares for someone with Alzheimer's or similar forms of dementia will find so distressing, because not only are they worried about what the person might do to themselves when they're wandering around at night, they might fall over, it's dark, they might trip on things, but also it disturbs the sleep of the person who's the carer as well. So it's not uncommon as we get older for sleep to be disrupted, and animals are no different, and animals get dementia like we do, and they, even though they live less long, they can get forms of brain damage or effectively erosion of the qualities of cognition as they get older, and that can include behavioural change.
And you can WhatsApp us, The Naked Scientist, with us through till 10 o'clock, 072-567-1567. You can jump the queue by calling 021-446-0567. Ian has done exactly that. Welcome, Ian from Durbanville. Go ahead for The Naked Scientist.
Good morning, Dr. Chris. Ian here. I often wonder when I microwave food that it doesn't destroy the food or the vitamin content. What do you say about that?
Oh, hello, Ian here. Yes, we do a lot of cooking with microwaves, and the way that works is that the microwave oven has a device called a magnetron, which produces electromagnetic radiation, effectively light, but at a frequency of about 2.45 gigahertz, so 2.5 billion cycles per second. And at that frequency, water molecules are very susceptible to being shaken around by those microwaves. And when you put something in the microwave oven, effectively the magnetron in the side sends a beam of microwaves out across the oven cavity. They reflect off the opposite wall and map back onto themselves, and you get this so-called standing wave pattern. It's a bit like if you drew a wiggly line across a piece of paper and then flipped it across the horizontal. So you've got basically a pattern mapping onto itself. When the food is in that pattern, water molecules, which have a distorted shape, a bit like a boomerang with a plus bit and a minus bit to the molecule, shake around as the microwave flips backwards and forwards. And that shaking effectively is like you rubbing your hands together 2.5 billion times a second, and that makes them hot. So the water molecules impart that energy to the molecules around themselves, and that heats the food up. Now, you can probably see where I'm going with this, which is if you've got a standing wave pattern, so you've got hot spots and cold spots, because where the waves are at a peak, you'll get a hot spot, lots of movement there. Where you've got the waves going across the midline, not much movement there. There's not much energy there. You're therefore going to get less heating in some places and more heating in others. And this is why microwave ovens have turntables, because you're turning the food and therefore the areas that get heated through that standing wave pattern to try to distribute the energy evenly through the food. The problem is that there will still be some very hot spots and some cooler spots in the food, and that can have the effect through thermal degradation of affecting the nutritional quality of your food. You'll get some very hot spots which might degrade your vitamins and your good foodstuffs and food components in that area, and you might get some areas next door that are less well cooked. Now, is that worse, though, than if you just chuck your vegetables in a pan of water and boil them up? And the evidence seems to suggest actually microwaving is better, because when you chuck your vegetables in a pot of water, the water softens the food, breaks down the cell walls and the cell membranes, and allows some of the food components and nutrients to leach out, which is why you cook your vegetables like your carrots in a pot of hot water, you get orange water, because the nutrients have come out of the foodstuff and into the water. We eat the food minus those nutrients and throw the water away very often. If you're sensible, you turn that into gravy or soup or something, and you can hang on to some of those nutrients. So the evidence is that actually steaming vegetables or microwaving them does appear to conserve more of the nutrition. Obviously, there are limits to how, and it will be very operator dependent. But it's probably not as bad as if you chuck vegetables in a pot of water and leach all the nutrients out that way. So we don't think microwaves are going to change the molecular structure of the food, but they will nevertheless have hotspots. So you will do some damage, but not as much food nutritional loss as if you boil the things up in pots of water.
Thank you, Ian, for that question. Question in from Fatima. Could you kindly ask the doctor why my blood pressure has been spiking randomly since being stung by a blubber jellyfish in the Arabian Sea 5 to 6 weeks ago? Thank you.
Oh, that sounds painful. I don't know. And obviously one's got to be very careful about attaching coincidences or labelling coincidences as significant, because it might be that the blood pressure was doing that before you hadn't measured it and you got stung. Now you've started measuring your blood pressure and you're saying, oh, look, it's spiking all over the place. But it wasn't anything to do with the jellyfish. It was always doing that. You just didn't look. But putting that possibility to one side, these sorts of venoms, which are in things like jellyfish, they are neuroactive. And it is possible that if it's doing something to your nervous system, it can affect things like the lability of blood pressure. We know that some of these venoms in some of these animals do that. They can rewire bits of your nervous system temporarily. They can also cause very strange immune reactions as well. But at the same time, it might be you worrying about the fact that what have been the consequences of being stung by this jellyfish, and worry and panic and anxiety also affects blood pressure. So there's a range of different possibilities here. I'm not sure what that jellyfish is or whether it really does have any neuroactive impacts, but there are a whole range of reasons why you might be seeing what you're seeing.
Okay, then we've got a question in from, can you ask, I don't know who this is, it's anonymous, can you please ask Dr. Smith his opinion on the US startup that was given regulatory approval to test a space mirror to beam sunlight back to Earth at night? What would be the various consequences or benefits of this?
Well, the whole idea about energy harvesting in space is a really good one. And in fact, the technology is quite far advanced, believe it or not. Now, the rationale for doing this is that on the Earth's surface, if you've got, say, a solar panel, every square metre of the Earth's surface is being hit by sunlight at the rate of about 1 kilowatt. So you've got about 1 kilowatt per metre squared of energy you can capture. If you go into space, you're going to get 20, 30 times that energy density. Why? Because as the sunshine comes through the Earth's atmosphere, the atmosphere attenuates and scatters the light, and so you've got much less energy left by the time you get to the Earth's surface. So if you put your solar panel in space, then you can enormously improve the efficiency and the amount of infrastructure you need in order to gather energy. What do you do with it then? Well, there are a number of possibilities. One, you could do manufacturing in space, and people are actively now exploring the possibility of capturing a lot of energy from solar sources in space and using that electricity to drive various manufacturing processes, like forges. You could capture things like iron-rich asteroids and then melt them down in space, and then use the microgravity to make very interesting mineral and metallurgical structures and alloys, which are much harder to make in gravitational environments on Earth. And you've got the extreme low temperature of space to achieve other interesting crystallization effects that you can make use of if you wish to. So that's one aspect to it. The other is that you could do your computing in space. Why build data centers all over the Earth's surface, which need enormous amounts of electricity to run them and enormous amounts of electricity to cool them? Put the computing in space, run it on solar power, and then you just beam the data backwards and forwards. And then there's another angle, which is a company I spoke to fairly recently. They are actually going to beam electricity from space. So their view is we could put arrays of solar systems in space, make use of the fact that you can get a lot more bang for your buck from solar power in space, collect a lot of electricity, and then you turn the electricity into a microwave signal that you beam down to the Earth to a big collecting dish. You collect that light, that microwave light, in the collecting dish, and then turn it back into electricity that you can put into batteries or put into the power grid. Now, this all sounds pie in the sky, but it's not. It's very much an advancing technology that people are taking very, very seriously. And I think the bottom line here is watch this space.
Okay, then I think let's go to James's question. Hi, Dr. Chris. Is there any cure for neuropathy? I'm not diabetic, James in Tableview.
Hello, James. What's neuropathy? Well, neuropathy, apathy means something's gone wrong or injured, and neuro means nerves. So a neuropathy is nerve damage or nerve dysfunction. And this happens for a whole raft of different reasons. James mentions probably one of the most common, which is diabetes. People with long-standing diabetes get what we call glove and stocking distribution neuropathy. Because the nerves that are longest in the body are those at the ends of your arms into your fingers and at the ends of your legs into your toes, they are the most vulnerable to chemical insult. And if you have high blood sugar levels for long periods of time, this compromises the linings or the sheaths of nerves and damages them. And also, people with long-standing diabetes might have problems with blood vessels, and this can starve the nerve fibres of a blood supply and therefore oxygen, and that can also make them go wrong. But that's not the only reason we have neuropathies. One other reason is because the immune system, for reasons we poorly understand, can sometimes attack nerve cells, or particularly the layers around nerve cells, and you get what's called an inflammatory demyelinating polyneuropathy, CIDP, chronic inflammatory demyelinating polyneuropathy. These are known about, they're documented, they happen. There are ways to manage them, but if they go on for too long and the nerves are damaged too severely, sometimes it's impossible to get them back. But the good news is that our peripheral nervous system does have very good regenerative capabilities. So if you fix the problem that's caused the issue in the first place, then you can get regeneration of peripheral nerves, different in the brain and spinal cord, but in the periphery, you can get regeneration, you can get some recovery, and in some cases, total recovery. So the bottom line is you've got to understand what's causing this. You need a diagnosis, you need to understand the mechanism of the disease, and then you can work out what the prognosis is and what the best treatment will be.
And we're going to have to wrap it there. Time approaching 2 minutes to 10 o'clock. With a big thank you to the Naked Scientist, Dr. Chris Smith, consultant virologist at Addenbrooke's Hospital. And yeah, you can get hold of him at The Naked Scientist. What's that website again, Chris?
You can drop me a line. It's chris at thenakedscientist.com. And you can also find this programme later today, as well as all of the other ones we've done for the last nearly 20 years of these phone-in programmes at thenakedscientist.com. I know 2008 is going to be a really big year, actually, because it will be 20 years since we started doing these programmes in South Africa. So we're thinking we should probably do something a little bit special.
Actually, we can't wait till 2028. If you can come around sooner, we can preempt that milestone. That'd be great, Chris. Thank you very much.